note 5.3, the end behavior and the turning points and degree and all that stuff. All this information about polynomials. So number 10, which we may not have gotten to in the lesson. So it's a fourth degree trinomial. The 1, 2, 3 trinomial. Fourth degree is a negative leading coefficient. Okay, so this one is a fourth degree. Let me write that in there. Fourth degree, negative leading coefficient. So it's upside down. We know what the fourth degree looks like because we learned it way back here, that the fourth degree looks like that. And it's either going to be up, up, or down, down if it's upside down. If it's flipped over, this one happens to be positive leading coefficient, so it's up, up, okay? And this also we did here when it's a degree that's even and it's positive leading coefficient, it's up, up, okay? So that would be true about this one as well. So we could say it a number of ways. We could say up, up, or we could say positive infinity, whichever way you want to say it, okay? I guess would be good enough for me. This one is let's see, the highest power is a 5. It's in standard form. It goes 5, 4, 3, 2, 1. It's standard form. Some of you messed that up on the quiz. Couple people. Okay, fifth degree. Boom, fifth degree. It's a positive leading coefficient. Surely there's no negative sign in front of that 9. Okay, and it's a, so it's a negative positive. You could say it with the arrows or with the infinity symbols. Highest power, the degree is 4. It's a positive leading coefficient, so it's up, up. Positive infinity. Negative leading coefficient, 7 is the degree, so it's an odd function, and it's a negative, so we know that it's going to look something like that, right? So we could say positive, negative, infinity. Okay. Determine if the sign of the leading coefficient and whether, find the sign of the leading coefficient, okay, is it negative or positive, and whether the function has an even or odd degree. Okay, well, this is, we can see both going in one direction, so we know that this is an even function for sure, because they're both going down or both going up. Since they're both going down, negative infinity, we kind of know that the sign of the leading coefficient is negative. So negative a x to the 4th power. So something like that. The sign of the leading coefficient is negative. You could just say sign is negative. Something like that. Either way is fine with me. This looks like a cubic. It looks like something x cubed. Whoops. Cubed. Okay. So it's got the sign of the leading coefficient because it starts down low and goes up high. So this is the regular positive leading coefficient. Positive leading coefficient. And let's make that a little nicer here. Coefficient. And we can also look back to see that that's true. Hold on a second. We said it's an odd degree. It's an odd function. One's going up, one's going down. And this should remind you of the standard parent function of the quadratic function, which starts down low and goes up high, similar to number 16. So you know that this is a positive x cubed function, right? Without graphing, check all the functions with the described end behavior. So we need something that has negative, negative, so both going down. So we know that it's an even function. So it couldn't possibly be that one. No. What else is it? Odd numbers? Any odd numbers, there's no way. Even function with a negative in the front, that's the only way that it's going to be going down in both directions. It would have to have a negative sign in the front. That one does not. So therefore, that one is out. This one has a negative sign in the front. Could be that one. And this one has a negative sign in the front. So, boom, boom. Let's see. Negative, positive. So it's looking like, this one is looking like that. And then going positive, up. Okay? So negative, positive. That's what it looks like on the graph. So it's an odd function. We know that. So we got to get rid of the even functions. No way on that one. No way on that one. It's not even function. It can't have a 2 or a 4 there. Odd function, 1, 3, 5, 7. Got to have a positive in front. So we'll cancel out all the negatives. And then we're left with the ones with positive signs in front. That's a positive 1. That's a positive 4. Yay. Positive, negative. So this is like that. And then negative, up and down. It's an odd function, going in different directions. That's why we've got positive, negative here. It's an odd function, so let's get rid of the evens. Whoops, boom, boom, boom. All the evens are gone. It's an odd function, so, and also you should notice that it starts positive, negative, and if you look carefully at that odd function, positive, negative is telling you that this is a negative leading coefficient. Okay, so get used to that. Negative leading coefficient. Where am I? Right here? Right here. Negative leading coefficient could be that one. That's got a negative sign. Could be that one, and it could be that one. Either of those are possible. Positive, positive, that means it's going up and up, both of them positive. And so that means it's even, right? So it can't be odd. So let's get rid of the odd numbers. Those are all evens, though. And it's got to be a positive because it's going up, up. So it can't be that one. That's a negative. That's a negative. So it could be that one, and it could be that one. And it could be that one. Okay. And that was the rest of your notes, your homework, where you have answers for that in your MyHebron.